Hi, Mr. Burke. I'm here to reassess standard 4.3 that I can solve problems involving springs and simple harmonic motion. Okay. So, the problem was pretty simple. It asked me to find first, omega. To do that, I simply took, the square root of the spring constant over the mass, to get 1.6 radians per second. And I also did all my unit checks. Next, I was asked to find the frequency because I know that the frequency is 1 over the period, because omega times the period is equal to 2 pi. Thus, if you want to find the number of cycles per second, you need to take the number of seconds in a cycle and basically invert it. I found that to be 0.269 cycles per second. Next, I simply found the period by doing 1 over the frequency to get 3.717 seconds. And finally, the most significant part of this question was the supposition that if I took it to the moon, would its period change? My answer was that it would simply not change, because as we can see, omega is equal to the square root of the spring constant over the mass. Nowhere in here is gravitational force or any other kind of force a factor. Indeed, the only things that omega is dependent on, omega's angular frequency, is the spring constant of the mass. Thus, the period will be the exact same, and here is my graphical representation of what this oscillation might look like. This is the y-axis, this is the x-axis, this is an unknown amplitude, and this is the time it takes for one period. And that's from the tip, that's from the maximum displacement to the next time that there is another maximum displacement, which is also equivalent to 2 pi over omega. Thanks for listening. Have a good evening.